Now today we will discuss memory interfacing. Now first of all, the definition is what do you mean by an interface. Now an interface is a concept that suppose there is your microprocessor, there is your memory, this is your microprocessor, there is your memory, and this is your IO device. Now the mechanism by which we can connect the microprocessor with the IO device and microprocessor with the memory, that mechanism is called the interfacing circuit. Now is the technical definition. As an interface is a concept that refers to a point of interaction between components and is applicable of both hardware and software level. Here we discuss in only the hardware level of interface. Next, the block diagram. The block diagram, I have said already that this is your microprocessor 8085 and this is suppose your memory chip. Now the microprocessor has some sort of address line, data line, controls line, and how we can connect these lines with the memory so that these two devices can interact with each other or talk with each other, or we can write the data into the memory or we can read the data out of the memory with the help of this line, and how these are connected by the digital logic circuit. So these are called the, whatever the circuit between them is called the interface circuit. Okay. Now next, interfacing pin. Now 8085 has different pin as is higher order address bus, lower order address bus, ALE, IOM bar, read bar, write bar. IOM bar is used for when this signal is high, it is for IO operation. When this signal is high, it is used for memory operation. Now this is read bar, signal used for read operation, used for write operation, and AD signal to used to synchronize the output device with the microprocessor. Next, address bus structure of the microprocessor 8085. As we have known that the microprocessor has 16-bit address line. Now within this 16-bit address line, lower order address bits are used as a multiplex address data bus. That means if we divide the address bus of 16-bit with 8 and 8, this is called the higher order address bus, this is called the lower order address and data bus. That means when the ALE signal is high, then it is used as address bus total as a whole, used as address bus. When ALE signal is low, then only this is used as data bus. The microprocessor identifies the address bus and data bus with the help of this ALE pin. Now this higher order address bus nothing to do with when the data bus is in action. Okay. Next, higher order address bus. The higher order address bus is a unidirectional bus. That means it carries the most significant bit MSB of, as I have said that higher order address bus, it is only unidirectional. Okay, so that is nothing to do with the data carrying. It only uses or carries the higher order bit or the MSB of the address. Now the lower order address data bus. Lower order address data bus is actually used to multiplex the address as well as data. Now as I've said that whenever the ALE signal is high, this is used as an address bus. When ALE signal is low, it is used as data bus. Now demultiplex address and data bus. Now demultiplexing is needed because your AD0 to AD7 is used as a lower order address bus as well as data bus. That's why demultiplexing circuit is needed for that purpose. Okay, demultiplexing circuit means we have to store, we did not lose the address. That means A15 to A8, that is higher order address bus, and A7 to A0, that is lower order address bus. Whenever this is used as a data bus, this is has to be latched somewhere. That means we did not lose the address of the point from where we want to fetch the data. So that's why latching circuit is needed or the demultiplexing circuit is needed. Now the demultiplexing circuit is, this is the demultiplexing circuit. Okay. Now this is the latching circuit. Latching circuit means whenever the ALE signal is high, this is your higher order address bus, add it, and lower order address bus is going to latched, going to store somewhere, and whenever ALE signal is low, this is used as data bus. This is the whole demultiplexing circuit. This is the demultiplexing LS373. With the help of this, we store the lower order address bus here, which is used to identify the address of a location from where data is to be written. If we lose the address bus, if we lose the address of somewhere, okay, then we cannot read the data out of which, whatever may be the data inside that, if we lose the address, then we cannot read the data. That's why this address, lower order address A7 to A0 has to be stored somewhere, which may be combined with A15 to A8 to get a whole 16-bit address. Then whatever may be the data inside that we have to store, we must not lose the lower order address. That's why with the help of this latching circuit we are storing this data whenever this ALE signal is high, okay, and when the ALE signal is low, our address is already been defined, that means stored somewhere. This address has been stored somewhere and this is already been given all the time, so we can use freely the lower order address bus as an data bus. Next, the control signal. Now I have said that whenever we interface the memory with the microprocessor, suppose this is your microprocessor and this is your memory, so certain operation can be performed. That means it can be, memory can be read, that means data can be read from the memory, and data and the memory write is data can be write onto the memory. And same case happens in the case of the IO. That means in the case of the IO, data can be read out of the IO and data can be read write into the IO. That means 4 operations can be possible: memory read, memory write, IO read, IO write. Now the microprocessor has a pin IO M bar. Okay, whenever this IO M bar signal is high, so this is called a memory related operation, and whenever this read signal is low, then this is an read operation. Next, in the case of the write operation, whenever this write signal is, in the case of the read operation, memory read operation, you can see that this is the control signal, whatever may be the signal. That means with the help of the IO M bar signal and the reads combined with the read signal, the memory read and IO read and the memory write, IO write can be generated, different signal. So these are the different signal. Okay, this is memory write, this is memory read, 1 1 here. So this is memory read, this is, you can say that the memory write signal can be generated with the help of this memory signal becoming high. That means if it is 0, M bar is 1, that means this is high, and read bar is 1, write bar is 1. So you can see that this is the memory write operation, this is 1 and this is 1. Okay, this 0 is going to convert at 1, so this is 1 and this is your 1. Like that, IO read and next your IO write. Next, in the memory interface. Now in the case of the memory interfacing circuit, memory is going to be interfaced with the microprocessor, and primary memory may be the RAM and the ROM, that is going to be interfaced with the microprocessor. Also the secondary memory, that means the floppy disk, hard disk, CD-ROM, magnetic tape and other device can be interfaced with the microprocessor. Now this is the important circuit. Important circuit means, suppose this is your memory chip, then the memory chip, suppose this is your N address line of the memory, this is your read signal, this is your write signal, this is your N address line, this is your chip select line, and this is your K output data lines. That means if the memory of the size is always represented by 2 to the power n. So suppose if the memory size is 1024, okay, then you can say that this is 2 to the power 10. That means 10 address line will be required to select different location of the memory. Memory is like a book that we have read. That means this is the first page of the book, second page of the book, third and fourth, like that, and each page consists of 8-bit data. So each location can be identified with different address. Okay, so the different address, if this is 10 address line, then we can uniquely identify 2 to the power 10 different location. So if there is 10 address line will be required for this addressing of this memory, or available address line is 10, then we can uniquely identify it 2 to the power 10 memory location, and within this each memory location we can store 8-bit data. Okay, and also read, write and chip select line is also there. Chip select line is required, that means whenever we want to select the chip or not, that means if there is microprocessor interface circuit, different type of memory, that means 1 2 3 4 memory has to be connected, and which memory we want to select, that will be decided by the chip select line with different logic circuit. Now the chip select line is selecting the chip. Okay, next, interfacing with the memory chip. The interfacing with the memory chip, your address line will be connected to this address line of this memory, and the IO ember and the read signal is always connected with different logic with the memory. Now interface with the two memory chips. Suppose there are two address line is available, A1 and A0, then with the combination of these two we can identify 4 memory location within the memory. This is 4 memory location within the memory. Okay, suppose there is two memories connected with the microprocessor, then A1 is connected to both this memory, A0 is connected to both this memory. With the help of the size of the memory is maybe 2 address line is available, that means 2 to the power 2. That means you can say that 4 memory location is available, and within that memory location we can store different data. That means this is your address, and we can store 8-bit data, 2-bit data, 4-bit data, whatever may be the data. Main thing is there is 4 possible location where we can store the data. There, suppose there is 2 chip, I have said that there is 2 chip. How we can identify which chip is to be selected at a time? So that is identified by this chip select line. Now you have seen that A1 and A0 is connected to both the chips. Okay, now this chip select line, this is CS bar and this is a NOT gate is connected, and whenever this chip is selected, this chip will not be selected. Now here the address will be 011 010 001 000. That means with the help of the chip select line is 0, we are identify this chip, and with the help of this chip select line is 1, we are identify this chip. So your whole address will be like this. In addition to the memory location, we are selecting the chip with the help of the chip select line. That's why extra bit will be required. Okay, now this is 2242 decoder. Now the 2242 decoder will be required if suppose there is 4 memory chip is to be connected, there is 2 signal S0 and S1, and with the help of these 2 signal we can outputting 4 different combination. With the help of the 4 different combination, that means this is 000001 1011. If 00 this is selected, that means this memory is going to be selected, and the rest of the line we can connect with the memory. Okay, so these 2 address line of the microprocessor we can use as a chip select line for the memory. Okay, so that's how it is worked. That means chip select line concept is used if there is different memory is to be connected, more than one memory is to be connected, then microprocessor has to identify which memory is to be selected at a time. That's why chip select line will be required, and that chip select line logic is to be provided from the microprocessor basic 60 from the within the 16 address line. That means if the chip select line is there, that means we are getting less number of address line to interface with the memory. This is your overall picture how is to be connected. This is your memory, 1 kilobyte of memory, and how this is read write and IM bar signal is connected with the read bar and write bar signal of the memory, and this is the chip select line is to be connected there, as there is 1 kilobyte memory. So 1 kilobyte memory means 1024. For the 1024 we require only 2 to the power 10. Then microprocessor 10 address line is to be connected, A0 to A9 is to be connected there. We don't require any address line here to uniquely identify the different memory location of this chip. That means this is 1 kilobyte, so you only require 10 address line to uniquely define 2 to the power 10 location. Okay, then rest of the line is used as a logic circuit to select the chip. Then rest of the circuit is rest of the address line will be connected as a chip select line, and microprocessor read bar, write bar and IO bar signal is connected to the respective memory location, IO bar signal, memory read signal, and like that. And the next video we will discuss practically how it is connected with the help of the 2 example. We will discuss how memory and the address different memory size is connected with the microprocessor with the help of the logic. Now this logic is actually important. I am repeating again, as there is 1 kilobyte of memory, so 1 kilobyte in 1024 byte. So 1024 byte means 2 to the power 10. So 2 to the power 10 means here only we require 10 at this line of the microprocessor to be connected with the memory. Rest of the line is used as a chip select line, and microprocessor read write signal is to be connected with the different logic. This is the memory MEM bar signal, MEMW signal connected with the memory corresponding. Thank you.